This short video will explain to you a little bit about the Stabilization Wedges project. In particular, you're going to be learning about different strategies that we can use to reduce our carbon emissions, and by so doing, help lessen the effect of global warming on our planet. First of all, what is this Wedges project? The Carbon Mitigation Initiative is a joint project of Princeton University, the BP Oil Company, and Ford Motor Company. They got together to find solutions to our current greenhouse gas problem. To emphasize the need for early action, two Princeton professors, Professor Sokolow and Pakala, created this idea of wedges, which represent ways in which we can reduce our carbon emissions using technologies that are available today. Each team of students is going to learn about the different ways to reduce carbon and select 8 strategies that they think are the best for our country and for the world. The greenhouse effect, which is one of the central factors in global warming, is actually not a bad thing. In this effect, carbon dioxide and other gases that are in the atmosphere absorb the heat that comes in from the sun. This heat is then re-released into the atmosphere and can increase the temperature. This isn't always bad. Without CO2 in our atmosphere, our planet wouldn't be warm enough to support life. So we do need some ability to hold heat in our atmosphere. Where we get in problems is when our CO2 emissions spiral out of control. Presently, 800 billion tons of carbon dioxide is presently in our atmosphere, absorbing energy from the sun and re-releasing it. 8 billion tons of CO2 is added yearly from the burning of fossil fuel alone. Unfortunately, only 4 billion tons is removed. Remember, plants take in CO2 doing photosynthesis, and CO2 can actually be absorbed into the water in our oceans. So we have a net gain of CO2 every year. There is significant scientific evidence that suggests this additional CO2 in the atmosphere is increasing our global temperature. The graph here shows just since 1954, a dramatic increase in the billions of tons of CO2 emitted into the atmosphere. Every time we burn coal or gasoline, we make carbon dioxide, and that's released into the air. In about 50 years, it's been estimated that we'll be doubling the rate of CO2 addition to our atmosphere. We could reach 16 billion tons in 50 years. The graph that you saw on the previous slide is not that drastic an estimate. Believe it or not, this emissions doubling theory falls somewhere in the middle of most estimates. Some scientists say we may have less CO2, some say we may have even more. What is very well accepted is that this path will lead to significant global warming, which could mean decreased crops, threats to human health, and even more extreme weather events like Superstorm Sandy. Also, the potential for melting ice caps, shown here, is going to change sea level and our weather patterns. Bottom line, such huge amounts of CO2 is not good for our planet. So what are we supposed to do as individuals? Well, through this Carbon Mitigation Initiative, a plan was devised to keep our emissions flat. Instead of continuing up this path here, what happens if we did things today to keep our carbon and carbon dioxide emissions flat? So we're not increasing, we're not decreasing, we're at least staying stable. If we were to do this, we would need to reduce our CO2 emissions by 8 billion tons a year. This creates this little triangle here in our graph that we're trying to prevent this CO2 from entering the atmosphere. And an easy way to think of this is we need 8 wedges, each of which representing 1 billion tons of CO2. The scientists involved in creating this project have established 15 strategies, each of which can reduce the CO2 emissions by 1 billion tons. The wedges, which is what they refer to these strategies as, are ways to either make energy with less carbon or no carbon, or ways to store CO2 and prevent it from entering the atmosphere. Again, there are 15 different strategies that exist, and they've been grouped into 4 basic categories. Fuel energy and efficiency, you'll use yellow to indicate those. Renewable fuels and electricity, you'll use green to represent those. Nuclear, you'll use red. And then switching fuels or storing carbon, you'll indicate those with your purple paper. I'm now going to give you a brief description of each of the wedges. Efficiency transport. We want to make our cars and buses more efficient. Today, there are about 600 million cars in the world, and it's predicted that there will be about 2 billion vehicles in the road in 50 years. What would we need to reduce our CO2 emissions in this wedge? If we doubled our gas mileage from 30 to 60, we could achieve the 1 billion ton savings. How could we do this? Hybrid vehicles, diesel engines, as well as making vehicles out of stronger but lighter materials. Another idea is conservation transportation. A wedge could be achieved if the number of miles traveled by the world's cars were cut in half. So carpool, carpool, carpool. Another way is through efficiency of buildings. If we make buildings more green in terms of using less heat, less energy wasted for lighting, by cutting emissions 25% in all new and existing buildings, we could achieve a wedge worth of emissions. Another way to save is in how we generate electricity. Currently, we produce electricity through coal. If we could double the efficiency on all of our electric power plants, we could save a wedge worth of carbon. Knowing that we're not going to completely throw out all of our petroleum-based fuel products, there are ways that we can decrease CO2 when we still use fossil fuels. This idea is called carbon capture and storage, and you can see a little schematic of it here, where the CO2 that's produced is then either stored back in the fossil fuel itself or perhaps put into some aquifer so that it does not go into the atmosphere. So 1 wedge worth of CO2 can be saved if we capture the carbon dioxide produced when we generate electricity using coal. Another way is to capture the carbon that's produced when we make hydrogen. Hydrogen-powered vehicles are something that's very desirable because the only byproducts of that chemical reaction is water, which has no significant negative effect on the environment. Unfortunately, however, when we make hydrogen, we also make a lot of CO2. So we could capture that CO2, store it, and then the hydrogen that we produce could be used to run hydrogen-powered vehicles. We could also capture the CO2 produced when we use coal to make liquid fuels. This syn fuel, as it's called by some people, could be used in places where we normally use gasoline, but when we convert the coal into the liquid fuel, we produce CO2. So if we store it, we now at least have more liquid-based fuel without adding CO2 to the environment. One of the most obvious ways is to switch from coal to natural gas. Natural gas does burn cleaner than coal. However, there's issues now with this idea of fracking and getting that natural gas out of the ground by pumping water and chemicals into the earth may have its own set of issues. But we could save CO2 if we switched from coal to gas. Nuclear fission currently provides only about 17% of the world's electricity, and this produces no CO2. So if we added new nuclear electric plants to triple the world's current nuclear capacity, this would cut our CO2 emissions by 1 wedge. Using renewable ways to generate electricity clearly is going to reduce our CO2. For wind electricity, 1 wedge will require 3% of the U.S. land area to be used for wind farms. That's a significant amount of land, but a significant savings. Solar electricity, similarly, would require a 100 by 200 kilometer field of solar cells in total in the United States to decrease our CO2. If we use the wind to generate electricity to make hydrogen, we could then use that hydrogen to power cars. Savings across several different sectors here. Biofuels, or growing plants that we then convert into usable fuels, would be another way to reduce CO2. Remember, when plants grow, they take CO2 out of the atmosphere. So when we burn those fuels and put CO2 into the atmosphere, we might have a net production of 0 CO2. So it's been estimated we would need to increase the world's ethanol production about 12 times to get 1 wedge worth of CO2 reduction. Plants, as I just mentioned, use CO2. So if we became better at preserving our forests, we would have more plants available to remove the CO2. 1 wedge would require stopping all deforestation that's presently going on in places like the rainforest. Another way to preserve our plants is to practice better soil maintenance so that we don't have erosion and we maintain a healthier crop base. There is a handout that explains a little more information on the 15 different strategies you can choose from. So if you're looking for more information, I can provide that to you. But now that you know a little bit about what you're trying to do, here are some final rules. You can use each of the 15 strategies more than once. Some categories of wedges, however, have limits on how many you can choose. If you look at the icons, each wedge will be identified as being either electric, heating, transportation, and so on. So you can only use at most 6 electric wedges, or 5 heating and direct fuel use, or 5 transportation. Other than that, you can pick your wedges in any combination that you choose. Once you've selected your 8 wedges, discuss with your teammates how your particular solution will be viewed by the stakeholders. And what I'm talking about here is completing the worksheet that comes in your wedge packet. It asks you to rate on a scale of 1 to 5 how taxpayers, energy companies, environmental groups, manufacturers, government officials, and developing countries will feel about your particular plan. So hopefully this gets you moving on your wedge project. Feel free to read the PDF file that's posted on Edmodo with all of the specific information about the 15 choices and the project itself.